two small spheres, each having mass of m kg and charge of q coulomb, are suspended from a point by insulating thread, each 1 meter long, each L meter long. Sorry, this is not 1 meter. Supposed to be L meter long, but of negligible mass. If theta is the angle each thread makes with a vertical when at equilibrium, show that q square is equal to this particular expression. So it's related to mg, that is weight of the object, related to length of the thread, sine square theta, tan theta, 4 pi epsilon naught. This is nothing but your k. So this is basically a combination of mg and the other one is your Coulomb's law. Is it not? What is the very first thing that we have to do? Yes, draw the diagram. Whenever possible, draw the diagram. Diagram always helps. Let me start a bit ago. So what does common sense tell? Again, just use common sense. Both are of same length, so we can draw the same length. Then we have two spheres. So because they have the same charge, they'll be pushing each other, right? Not pulling. And of course, gravity also acts. Let me just write all the forces first. And what else acts? Yes, the thread. You guys have studied all this. You should be experts by now. So this should be a cakewalk for you guys. After this, I've given you enough clue. You can pause and think over. So what is that we are looking at over here? This is nothing but your S theta. That's your L. Now I'm labeling. That's your mg. That's your Fe. And that's the force because of the thread. And what else? We're calling that as O, A, B. And we need this length also. Let's call this as 2x. Right? My trick is always use 2x whenever we have to divide. Is it not? It makes it convenient actually. And yeah, let's label this as P. Right, this is what we are looking at. So working, let's write the obvious. See, even I don't know how exactly we'll reach there, but let's write the obvious. I always do that. I'll just write the obvious, then things will appear by itself. That's all you guys have to do, guys. Free body diagram of right sphere. So we are looking at again, just writing the obvious. Force to the right, a force down, and a slanted force. Then we have this to be our theta, right? Then this is our mg, fe, and that's our ft. Okay, I hope you guys understood how we got theta. That's because this is your alternative interior angle. Okay, guys. So if I draw a line which is perpendicular, so obviously that will be alternative interior angle. Now, if I resolve ft, what happens? This would be ft sine theta, and this would be ft cos theta. Yeah, I didn't do a good job. I don't have enough space. Cos theta. Okay. So let's do the obvious. Since the object, in this case sphere, is at equilibrium, what can we do? Yes, we can equate. What can we equate? Ft cos theta, I can equate it to weight of the object, and Ft sin theta will be equal to force exerted on the charge, or in this case sphere, because of the other sphere, and that's equal to k times of q1 q2 by the distance square. Now what else can we write which is obvious? So I think this is good enough. Okay, let's have a look. So what do we need? We need to somehow equate mg and all of this expression. How will we do that? Yes, the very old method, dividing 1 with 2, or 2 with 1 in this case. 2 divided by 1. So 2 is tan theta, and 1 is, 2 is sin theta by cos theta, that's tan theta. I'm directly writing it. And this is k q square by 2x the whole square. And in the denominator, we have mg. A bit of rearranging. We need expression for q square, right? So this will be tan theta 4x square mg by k. K is nothing but 1 by 4 pi epsilon naught. So we almost have the answer. But here we have an expression for L square and sine square theta. Where will we get that? Think. Yes, from triangle OPA. Right? We don't have x square over here. We need to get an expression for x square. So from triangle OPA, a simple diagram. This is theta, this is L. So this is opposite L sine theta. And this is also equal to x, right? Because this is midpoint. Therefore, x is equal to L sine theta. And let's substitute in 3. We'll call this as 3. Therefore, q square, again, all of this I'm doing by taking a normal natural flow. Nothing fancy. I'm just letting the mat do whatever it is showing, I'm letting it guide me. 4 pi epsilon naught. Is that the answer? I think so. It looks good. Right? It's as simple as that. Is it so? 4, we have mg, we have L square, sine square, theta, tan theta. Done. That's it. A question which looks so difficult. It's very simple. All I did was draw the diagrams. All has to do with the diagram. And then again, another diagram, free body diagram. And simple resolving of forces. And done deal. Bit of trigonometry here and there, and you are done.